morning, everybody, or good afternoon, depending on where you are in the world. So thanks for joining me. My name is Josh Long. Those are my Twitter coordinates up there. If you guys are on Twitter, if you guys are out there or have questions, please feel free to add me on Twitter. Feel free to send me an email, josh.long@springsource.com. I'm very happy to answer questions. I work for SpringSource. I am the Spring developer advocate. Author of several books on Spring. I think now 4 or 5. Working on my 5th, I think. I'm also a contributor to some of these projects on the screen here. And every Tuesday, which is 2 days ago, I put together a roundup on springsource.org called This Week in Spring, which collects all the great tutorials, all the great news, all the sort of interesting stuff happening in the community in one place on our website where you can find it for your consumption every Tuesday. All right, like I said, as I said, don't hesitate to reach out to me. I'm very happy to answer any kind of question you have about sort of the open source Spring source bits, okay? Okay, so quick recap. We have a lot to cover here, but I'm going to go ahead and let's just review some stuff before we dive into the meat of it, okay? I want to make sure we're all on the same page, kind of a equalizer, section of the talk. So first things first, why are we here? We're here because we're using Spring. Spring is a framework. I like the definition given by Bob Martin for the definition of a framework. He says software entities, classes, modules, functions, etc. should be open for extension but closed for modification. We're of course also here because above all else, we should strive to not reinvent the wheel. If you reinvent the wheel, bad things happen, and there's rarely any reason to. And with today's applications becoming ever more complex with a lot more moving parts, everything you can sort of reuse is a win, right? You save a lot of time, you'll save a lot of energy. For those of you who have been using Spring for a little while, you'll probably have seen this deck or this slide or something like it. But the basic idea is that Spring itself is just a component model. It provides a bunch of very convenient utility libraries on top of it. That component model sort of insulates you from the underlying platform. Historically, that has meant that people have been able to use more classic application servers like WebSphere and WebLogic and use Spring just fine and even be able to evolve and advance their application. And as they've needed to, they've been able to move to lighter, more agile application servers like Tomcat. Okay. Increasingly, we're seeing people move from more classic application servers now to not just lightweight platforms and application servers like Tomcat, but also to the cloud, where Spring serves particularly well because, again, it gives you that sheen of portability. When you build on top of the Spring framework, you're building on top of a component model, as I mentioned. You also have access to lots of libraries and utilities that are very, very convenient for building applications today. In particular, there's support for building web applications, rich in internet applications. We'll look at, of course, a lot of that today. There's support for building highly concurrent transactional service tiers, for handling batch processing, for handling messaging and integration, enterprise application integration solutions, big data and small data, medium data, and mobile. And, of course, we'll look at that as well today. So there's a lot to be had if you just know where to look in the Spring framework. Okay, so having gotten that out of the way, let's review some of the sort of core Spring web support, okay? When you think about Spring, there's Spring core, and then there's web support in Spring, and then on top of that, there's Spring MVC. So we're just going to look at the low-level machinery for dealing with web applications with Spring, not Spring MVC just yet, okay? Just because I want to make sure we're all on the same page and kind of have a working knowledge of some of the cool stuff that's out there, right? Okay, first things first, the dispatcher servlet. That's the sort of heart of all this support. It's a servlet that knows how to bootstrap your application context and expose it for consumption via a servlet-based application. You can use lots of the machinery that comes with Spring for building web applications without having Spring MVC, okay? And typically you're going to do this if you're working with some other web framework, or if you're using if you're using Spring and you still want to be able to access your services from a servlet environment. There are also convenience objects that are really, really useful, but sort of limited in scope. For example, the delegating filter proxy allows you to manage a Spring Bean, and avail it of all the lifecycle benefits and all the services that Spring provides, but then expose that bean as a JavaScript filter, something that can consume from a servlet container. Another convenient object is the HTTP request handler, which is a very low-level endpoint class, and we use that, for example, in all of our support for RPC with Coucho, Resin, and JAX RPC. I mean, there's lots of these. I won't bother going over all of them. One particularly useful one is the Web Application Context Utils. It contains a static method that expects a reference to a servlet context, and given a servlet context, it'll give you back a reference to the configured installed application context. So this is very useful if you just want to access your beans and you have no other way of getting them injected correctly. This will give you back a working correct pointer to the application context. Above and beyond the low-level Spring web machinery, there's integrated support for lots of different web frameworks. Okay, so chances are, if you're using a web framework, there's probably a very good Spring integration library or Spring integration story available for that web framework. Spring by itself, out of the box, ships support for Java Server Faces 1 and 2. It ships support for struts. If we don't have support in the core Spring framework, then it's very likely that the web framework itself does. So, for example, Tapestry and Wicket and Vaadin and Struts and Play all have good integrations for Spring, and they make it very easy to consume Spring Beans within that environment. GWT works very nicely with Spring applications, and there's good support for that in Spring Roo. Flex, our support for building Flex-based rich internet applications is unparalleled. We have the most convenient way of exposing our services to Flex applications called Spring Flex. So there's lots of good support there. It depends on what you're trying to do. But chances are, if you're using something besides Spring MVC, that's okay, right? This is all about choice. We support lots of different options. Having said that, my personal bias, and of course it might just be, years of having used it and consumed it. My personal preference these days is Spring MVC. Spring MVC is a classical Model 2 MVC compliant web framework, right? The MVC paradigm is pretty simple, but if you truly haven't, seen this one slide in a while, if it's been years, basically we have the dispatcher servlet. The dispatcher servlet is the front controller. It accepts requests coming in to the web server. It forwards those requests to all the configured controllers and asks which of them are able to handle the request. The controllers are beans that you will provide. These are Spring beans that you provide business logic in. The controller fields the request, handles it, does some sort of work. Perhaps it reads data from a database, bundles that up, and puts it in something called a model, which is basically a glorified map. That model is made available for rendering inside of the view. And that model is then sent back to the front controller, where the front controller finds the correct template, the correct quote-unquote view, renders it, and then makes that data available. So this is a very, very simple pipeline. Fundamentally, this hasn't changed since day one. And if you understand this pipeline, if you understand the life cycle, it can be much easier to reason about how your Spring MVC application is working. Okay, so let's take a very, very quick look at modern day Spring MVC. Okay, this is, when I say modern day, I'm talking about anything after Spring 2.5, right? This is the @MVC component model, the controller, the annotation-based controller, definition model. So first things first, we have a regular class here. It's a Spring MVC controller. You can tell because it says controller, right? @controller. That tells Spring that this bean is a managed bean to be included and packaged up by the application context, and that it should be made available for consumption via the web as an HTTP endpoint. We can tell Spring MVC that in particular we want this URL, the URL of my resource, to be available, and we want it to support all the different types of HTTP verbs. In this case, we're just you can imagine accessing it from a browser, so that'd be an HTTP GET. Oops. We can specify which kind of method, though. We can actually say, okay, well, this URL is only available for HTTP GET requests, not posts, not deletes, not puts, etc. We can declare arguments in our Spring MVC request handler, the method here. For example, here I'm accessing the raw HTTP servlet request to avail myself of some of the information that I can only get from there. But I recommend on the whole that you avoid depending on the raw HTTP servlet request. This unnecessarily ties your application to the servlet API and makes it, more difficult to unit test, to mock outside of the container. If you keep your argument declarations sort of clean and free of any of the servlet types, then you have a very clean and mockable API, right? This is just a regular bean with a method for the purposes of unit testing at this point. So here I'm using the @request param annotation on an argument, and Spring MVC will see this and it'll say, okay, I need to pluck the search request parameter out of the request and then make that value available as this argument when this method is called, when I invoke this method. I can take advantage of bookmarkable or so-called SEO friendly URLs. Here I'm taking of my URL as URL of my curly bracket ID curly bracket. The curly bracket is called a path variable. That value is a wildcard. When Spring MVC sees that, it'll substitute whatever's in that parameter, in that place, in the request, in the URL, and extract that value and put it and make it available as a path variable, which we can inject as an argument into our controller here. So we're saying @path variable ID. I mentioned the model, and that's a very important part, right? You need to communicate business state. You need to communicate business data to the views, right? And so the way to do that is to inject a reference to the model itself. The model, as I mentioned, is just a very glorified hash map, keys and values, right? So here I'm saying model.add-attribute customer, and I'm calling a service which I've injected into my controller, looking up some data, and then returning it, right? That gets made available to the view. Up until now, I've been returning just a string from these controller methods, right? So public string, process the request. The string that we've been using, this is actually a view string, right? It's a string that will be used by Spring MVC by the view resolver strategy in particular to look up a view, right? So in this case, if I have an internal resource view resolver configured, I might stipulate that whenever Spring MVC sees the string home, it's to prefix it with web-inf /views / and then suffix it with .jsp, and that creates a full view that Spring MVC can render and send back to the client. But it keeps our code sort of decoupled from the details of which view technology we're using. We could just as easily tomorrow swap out JSP for timely for velocity or some other view technology. We can, of course, short circuit that process, right? We don't need to rely on the view resolution process. We could just programmatically construct a view subclass. Here I'm constructing an XSLT view. You might, for example, also construct Excel spreadsheets, CSV data, PDFs, these kinds of things, right? Things that you want to render, but you can programmatically build it up inside the controller. You can also send back just raw bytes, right? So, for example, here I'm allowing a request to come in, and then, for example, I might want to stream an image or something like that. It's very easy to do that with Spring MVC. Here I'm setting a response entity with a payload of type byte. I'm packaging in the bytes, and I can also set headers and things like that as well. Okay, so that was a very, very, very quick run-through of sort of the controller model for Spring MVC as of 2007 or so. Let's take a quick look at some code, okay? If you guys are following along at home, I encourage you to take a look at this GitHub repository, github.com/JoshLong /a-tour-of-all-of-springdom. It's a repository that serves as the code for a 3-hour talk that I do, In particular, though, I've got the code for everything we're going to look at today inside of this mobile MVC folder. So web/mobile MVC. If you guys want to look at the code, and access it and try it yourself, please feel free to take a look at this. It'll help you out and get started quickly. I have this code already checked out into the Spring tool suite. This is the open source Eclipse distribution that we release that builds on top of the latest and greatest Eclipse bits. In particular, this IDE comes pre-integrated with lots of plugins that you would otherwise spend lots of time tediously, configuring and installing by yourself. It already has sort of been tested, and the latest greatest security patches have been applied and all that stuff. And we typically release this very quickly after the Eclipse release. So if you want a stable, integrated environment, this is a good bet. It also has really nice support for building Spring applications. So, for example, if you wanted to build your own Spring MVC application, go to File, New, Spring Template Project, and you can easily just choose Spring MVC project there and get started very, very quickly as well. I have the application that we're looking at checked out, okay? So the first thing we're going to do is we're going to look at configuration, right? This is a Java configuration styles config class. But don't let all this fool you, right? Let's take a look at this. That, my friends, is actually the most plain working Spring MVC configuration. You don't need all those other things that I had in there, right? This is if you haven't seen this style before, this is a at configuration class. When Spring MVC sees this class, it'll load it, inspect it for any methods with @bean on it, like this. And then when it sees those methods, it will call the method, take the value that's returned from the method, and make that available as a bean for injection inside the application context, just as if you had defined the bean inside of your XML, okay? You could, with this configuration, do a lot. You get a lot out of the box just by using @configuration and @enable web MVC. If you're using XML, then the same thing is, you can use the MVC annotation driven element in XML. It's the same thing as the @enable web MVC. They both install and set up all the sort of machinery for Spring MVC. Once you've done that, though, the nice thing about, one of the nice things about Spring MVC is that while the conventions are good, it's very, very, very flexible. You can tune just about every part of it. So let's go ahead and reintroduce some of that stuff from before. The first thing you'll note is that we're extending a base class. This base class is simply an implementation of an interface called Web MVC Configure. This base class is this interface is just a bunch of callback methods that Spring MVC will call when it sort of starts itself up and it needs certain parts of the engine to be plugged in. This gives you an opportunity to provide those implementations, okay? So, for example, if you want to configure message converters for handling the way Spring MVC marshals data to and from HTTP and objects, you can do that here. If you want to override the validator that's used, right? So JSR 303 or some other custom validator. If you want to teach Spring MVC about specific types of arguments that might be passed into controllers that it doesn't already know about, just add it here. So if you want some other object to be made available to you, you can create the strategy, the recipe for that, and teach Spring MVC how to do that. The same thing applies for return values from those controllers. So before, we've been returning strings and views and input streams. You could teach it about some other object that's important to you here if you wanted. Exception handling, right? You can actually teach Spring MVC new tricks. You can teach it how to resolve and handle certain types of exceptions. You can register interceptors. Interceptors are the sort of a Spring MVC equivalent to a filter. They give you a chance to intercept and behave, and act on all HTTP requests. But this component is aware of the Spring Bean lifecycle, so it'll respect all that. A common thing that a lot of people like to do is just have a page that is just available for rendering. There's nothing particularly interesting that has to happen in terms of business logic, so there's really no need for a full Spring controller. You just want to render the template. You might, for example, have a static HTML page for, the contact page or the About Us page or whatever in a typical application. There's no need to set up a controller, so you just tell Spring MVC you want to register the controller as a view, so it'll just render the template directly. You can configure the default servlet. The default servlet is what all servlet containers have a default servlet. The default servlet is the servlet that's in the container that registers that renders requests that don't otherwise have a servlet mapped to it. So, for example, if you map your application in your configuration in your web.xml, if you map your application to /foo, and you make a request to /bar, and that's not otherwise mapped to a servlet, the default servlet will handle that. Typically, this is good because you have a fall-through to handle things like CSS and JavaScript and so on. These default servlets tend to be optimized for rendering static resources. So it's a very convenient servlet to have at your disposal. Unfortunately, if you map your application to // which is common, right? You want your application to sit at the root of the web context, then you lose the ability to take advantage of the default servlet unless you turn on this feature. So you say configure default servlet handling, and you enable it. And the reason you have to enable it is because the default servlet lives in different places, in different containers. Spring MVC is really smart and knows about a lot of them, but it doesn't know about all of them, and so we can't guarantee it'll work consistently. It's not part of the standard or anything, right? Okay, so with that said, let's kind of look at what we're doing in our configuration class. First things first, I told you before you can register beans to override certain parts of the machinery. In this case, I want to override the way view resolution is handled, right? I'm going to say to Spring MVC, whenever you see a view string, it should be handled by this class called tiles view. Tiles will search for an Apache tiles definition that matches the string that we've passed. So in our previous example, it would look for a tiles definition with a view ID of home, okay? Apache tiles itself is pretty gnarly and pretty complicated to set up, so we can use the tiles configurer object. That installs all the moving pieces so you don't have to worry about it. Here I've turned on the default servlet. I can add resource handlers here. For example, I can say to Spring MVC, for everything in the JS and CSS directory, just go ahead and render it directly. You don't need to, just go ahead and map /JS / to, whatever resource is actually there. Just go ahead and pipe it out, right? And then we also register a few different interceptors, in particular a device resolver handler interceptor, which we'll look at when we talk about Spring Mobile. Once you've done this, once you've kind of changed everything to your heart's content, you can now start writing code, right? In my example here, in this little code here, we've got a controller that deals with customer data. It's a very sort of simple thing, right? We've got a service that's been injected. We've got a controller with, endpoint here. This endpoint is mapped to /. It accepts HTTP GET requests. It expects a request parameter called ID, but it's not required. And it puts data in the model and makes that data available for view, right? In this case, the view is customers / display. So as I mentioned, that's going to, delegate to some sort of strategy. In particular, in this case, it's going to look up the strategy via tiles, and that view string will map eventually to customers display.jsp, right? Customers / display.jsp is a simple HTML3 even. I'm not, it's nothing fancy at all. It's just a very basic JSP page. I'm sure we've all seen pages like this before. The model data that we looked at is, dereferenced inside the template here. So $, curly bracket, customer.id, curly bracket. That's dereferencing the customer attribute that we've put in the model back here in our code. And with that, you have sort of a working, sort of a full-fledged basic Spring MVC application. Now, that's good enough. I'm sure we've seen that kind of stuff before. I only bring it up because I want to make sure we're all on the same page and we have a kind of a common familiarity with the existing Spring MVC component model. It's very important to sort of keep our eye on the horizon, but I want to, kind of revisit the origins here of HTTP and the internet. So before we can understand the new stuff, let's look at some of the really old stuff, okay? A long, long time ago, A long, long time ago, there were computers, very, very dumb computers that roamed the earth at the same time as the dinosaurs, or maybe they didn't, I don't know. But these computers were, they came in two varieties, green screen and amber screen, and everything was black, otherwise the screen was black. These are very, very dumb clients. These terminals could be used to connect to very, very smart servers, mainframes, but they didn't have any client-side state. All the state on the client was sort of lost, right? Each time the screen re-rendered, all the client-side state was really kept on the server. And this wasn't a very good approach, right? Not only was this approach not portable, for example, a client application written for one terminal might not work on another, but it also meant that you kept all the state on the server side, which is no way to run a railroad, right? It won't scale. Then, in 1990, 1989, Tim BernersLee, a gentleman working at CERN in Geneva, on a Next Cube. These are the machines that Steve Jobs created and started selling after he was ousted from Apple in the 80s, working on a very Unixy sort of workstation. Tim BernersLee created the very first HTTP client and the very first HTTP browser. And this is a really kind of awesome thing, right? I mean, look at this sticker. This is the sticker that was on his machine. And I love the implication of this sticker. The sticker says, "This machine is a server. Do not power down." And I just love the idea that at some point, some unsuspecting lab assistant or whatever might as easily have sort of trotted across the lab and accidentally tripped and fell on the cord, keeping that server alive, And at that point, that one guy, would have been responsible for having taken down the internet. Anyway, we can't do that anymore, but it's just kind of an interesting thought. Wouldn't you love to be able to find the one big cord and just go boom, and just unplug it and watch everything go dark just for a minute? So anyway, this is the original HTTP server. He did a very good job. The original HTTP browser, the client as well. But HTTP and the formats used on top of HTTP, like HTML, were very plain, right? These formats worked, but you really didn't have a lot of sophistication in terms of the client. And for a lot of reasons, we sought ways to create better clients, but we did the same old thing. We put the client-side state on the server, right? And that really sort of misses the point, right? We still didn't fix the problem. We have clients with really, really bad, really, really unsophisticated clients, and they don't have the ability to do a good job of holding client-side state. So we fixed, and I use that term charitably, the problem by creating hacks, solutions, if you will, right? These solutions are things that mimicked component models on top of the server and kept all the client-side state and RAM on the session in the server side. You guys can probably think of a few frameworks that work like this. But generally, I think this misses the point. And it reminds me of this Dilbert cartoon. Dilbert, of course, approaches the pointy-haired boss and says, "I'm grossly underpaid. I want a raise." And to which the pointy-haired boss responds, "Oh, Dilbert, Dilbert, Dilbert." Dilbert responds, What? "People don't work here for the money," continues the pointy-haired boss. "They work here for the challenge." "Well," Dilbert reasons, "if challenges are more valuable than money, then why don't you give me your money, and I'll give you my challenges?" And of course, the last panel is the pointy-haired boss thinking to himself, "I must kill him before he infects the others." This is sort of how I think I imagine a lot of people approach this problem. They're not really interested in the money. They're interested in working hard, and that doesn't. There's no way to solve this problem, We need to work smarter. And the good news is we actually did, right? So around 2004, there's a very specific day. I forget the actual day now, but at one point, DHTML, the term DHTML, was replaced with the term AJAX. And we discovered AJAX, which allowed us to connect our applications to services in the back end in a convenient way. And suddenly, my goodness, the floodgates of awesome apps just broke, right? We've seen so many amazing things. Witness Google Maps and Gmail. These things were revolutionary when they came out, the interactivity, the dynamicism of these applications in the browser. And over time, we started doing things with the DOM and with JavaScript and creating more and more sophisticated, elegant, beautiful user interfaces using things like jQuery, right? Eventually, these applications grew sophisticated enough that consensus was gathered on how to sort of put all these hacks and tricks and special effects and all these things that we've all worked very hard to create, and how to commoditize them, how to make them part of the platform. And that was sort of the beginning of the HTML5 working group, which now comprises support for GIS, geolocation, 3D graphics, 2D graphics, audio, video. I mean, truly sophisticated stuff, amazing stuff. That work has continued, and you can already see a lot of HTML5 support in any contemporary browser. And people have built amazing applications with this stuff, right? We've seen some amazing stuff, sophisticated things. People have built applications of sufficient complexity that at some point they started to see the same organizational challenges as we see on the server side when building web applications. You need a way of controlling and arranging your controllers and arranging your views and sort of keeping them separate, right? That same MVC paradigm is very, very valuable on the client side as well. And so this has seen things like Backbone.js and Angular.js, which are MVC frameworks on the client, right? So you've got some amazing options now, right? And of course, when I tell people about this, they say, well, Josh, really, how powerful is HTML5? How powerful is JavaScript, the language that, of course, you have to use to build these applications? And for those people, I say, check out Fabrice Bellard's JS Linux, okay? BELLARD.org/JS Linux. This is a full x86 emulator that loads basically the equivalent of an image, a kernel image, in memory, and then runs the whole thing in the browser. I'm not kidding. There's no server-side state at all. The whole thing just happens in the browser. This is using support for typed numbers, right? Typed numbers means that you now have the ability to do bit twiddling inside of JavaScript. And as soon as you have bit twiddling, well, surely you must, apparently the natural thing to do is to write an x86 emulator. So this guy did, and it actually boots Linux. And if you launch it, it'll dump you into a shell, whereupon you can find a C file. If you open up the C file in VI, you can make changes to it, do whatever you want, and then recompile it and then run the program all in the shell inside of your browser, right? And that's JavaScript. I'm not going to sit here and tell you it's the fastest language I've ever seen, but that's pretty good. I mean, if you can boot Linux, man, I mean, wow, we've arrived. You can boot Linux in your browser now. So there's really, in all likelihood, there's probably nothing that you're going to ever want to do that you can't do inside the browser, right? So look to the browser first if you can. Avoid things like Windows Forms and GTK if you can help it, right? In all likelihood, you can probably solve it this way. Okay, so we've done it. We've done a good job. Our browsers are really smart now, right? These are not the dinosaurs that roamed the earth 20 years ago. These are some very, very smart clients. And so the question is, okay, I no longer need the server so much. I don't need it certainly to hold my client-side state anymore, but I still have some state. I have business state. How do I communicate that, right? Well, it turns out the answer was right before us, right? It's right underneath our noses. It comes in the REST architectural pattern that was espoused by Roy Fielding in his 2000 doctoral dissertation. Roy Fielding describes REST, or representational state transfer, as a way of taking advantage of the basic fundamentals of the internet, the basic fundamentals of HTTP, and using that to build services, web services. And he talks about a couple of different principles. I'll talk about those here. One is use the HTTP verbs that are already supported and that already understand and that already deal directly with this idea of the mutation of state. So, for example, post, get, and put, and delete. Use those verbs to handle the lifecycle transitions for your data, your enterprise data, right? So if you think about it, these HTTP verbs handle creation, reading, updating and deleting at a minimum. They also support other things, but at a minimum, they support those verbs. And really, that's all we ever try to do with database data, right? That's maps very naturally to that. So it's very easy to see how you would map HTTP resources to, CRUD or repository type information. Services in REST, he says, should be stateless. The web is stateless, and so should your services. So probably best to avoid, state if you can help it, or at least move it up to a place where you can handle it better. Resources should be unique and should identify things uniquely. So, for example, a lot of people use directory structure like URIs because they can map very nicely to hierarchical data, and it works very much like a file system directory structure. And of course, web services should be easy to consume, right? At that time, you might have used XML when this paper first came out. Now, today, I think JSON has become very fashionable and very much in vogue. So people are using that a lot as well. And that, of course, is the native, that's the most natural way to communicate with the browser. So there's a lot of different ways of working with RESTful services, but fundamentally, they should be easy to consume, right? They should be natural to consume if you already know how to work with HTTP. And this, of course, brings us back around to Spring MVC. Spring MVC has great support for REST. Spring has great support for REST. Spring MVC can be used to stand up and expose RESTful web services. And then, of course, on the client, JavaScript and HTML5 both know how to speak JSON. They both know how to consume RESTful web services. And, in fact, all platforms have an HTTP client, right? It doesn't matter what platform you're using. That's the nice thing about this. You don't need a complex tool to code generate some sort of client-side proxy based on a type or anything like that. You don't need IDL. You don't need anything, right? If you have C or POSIX compliant operating system or any programming language from the last 20 years or mainframes even. I mean, almost anything now you can find a HTTP client, right? So it's very easy to do good things here, very powerful things. Spring's client-side story for REST is something called the REST template. The REST template is available as of Spring 3.0, which came out in 2009. The REST template reduces common HTTP access operations to one-liners, right? And it supports marshaling data back and forth from, say, a JSON object into a Java object, or an XML document into a Java object. It's just a very nice, convenient class to use. To demonstrate this, I like this example here. This is the Google search API, right? So you can actually do a search on the search engine and get the results very, very quickly in just 3 lines at the top here. I mean, that's pretty powerful, I can remember, 15 years ago, we all thought, well, I'll take this palette full of EJBs or maybe it was, they also had COM, right? Do you guys remember COM, DCOM? This idea that you have these components in a palette, and you should be able to drag them and drool them, and suddenly you have this interesting business functionality. And that marketplace that was supposed to emerge never really did, right? We never really got this burgeoning ecosystem of reusable components that you can add and build upon. But now we do, right? They're just web services. They're just very, very simple web services. In 3 lines of code here, I've managed to link, to use the parlance of object linking and embedding, and then embed and reuse the most powerful search engine in the world in my application. I mean, that's a game changer, right? And this is just one of a zillion and 12 different web services. As another example, I have my own sort of fictitious hotel booking website. You can see here I've got a URL that demonstrates a hotel and then booking data for that hotel. And you can see it's hierarchical and it requires parameters, right? So the URL has 2 path variables. Those path variables are satisfied in the 3rd line when we specify the query parameters, right? So 42 and 21 will get mapped to the hotel and booking path variables, respectively. The REST template itself is very convenient. As I mentioned, it has options for working with all it has methods for working with all the common HTTP verbs. If any of those methods don't meet your use case, then you can use you can use the 2 fall-through methods, execute and exchange, for more power. Those expect callbacks, but give you full control, if you like. On the server side, it turns out that working with REST is very much like working with just regular Spring MVC. Nothing special at all, in fact. So here's our existing controller. I've added a new method. In this case, I said, public @response body customer, right? So the return value is different here. Here I've got a regular POJO, a domain model object called customer, and I've annotated the return value with @response body. When Spring MVC sees @response body, it also short circuits the view resolution process and attempts to convert that POJO, that object, into an HTTP representation by delegating to one of the configured HTTP message converters. By default, you have on your in Spring MVC, if you configure nothing else, you have support for JSON conversion if you have the Jackson library. If you have JAXB on your class path, you have support for converting to and from XML. If you have Rome, which is a library for working with RSS and Atom feeds, then you can automatically convert to and from those kinds of objects as well. If you have java.auth.buffered images, you can convert to and from that, right, for buffered image data. You can load that up into an image primitive. I mean, you can do a lot of different things by the the already configured ones. Here, I'm telling it to convert this, however possible into a customer object. I can do the inverse as well. I can say, okay, instead of retrieving data by HTTP getting that URL, I can post to that URL. I can post data, and I can ask Spring MVC on the server side to make the incoming request body available to me after conversion as a customer object. So here I've got @request body on the incoming payload, and then customer, and then I've got the data itself. So this is very convenient. You can still create strongly typed HTTP endpoints if you like. And of course, with these facilities, all the existing stuff is still there as well, right? So path variables and all that stuff still works just fine. You can also set up HTTP status codes, right? That's another thing that's kind of nice to know about. So, for example, with REST, it's common that whenever someone posts data for creation, you should return not just HTTP 200, which means everything's okay, but HTTP 201, which means that the resource that you submitted was created and put on the server, and typically you'll return a location header telling the client where that resource can now be accessed, right? So, for example, it's very nice to be able to declaratively say that the status code for this, if everything goes all right, is HTTP 201 by using the @response status annotation. Okay, the astute among you are probably looking at that and going, okay, well, that's all very well and good, Josh, but you're forgetting something rather obvious. HTTP browsers today only speak GET and POST, which means that if you've exposed RESTful services using delete and GET and all that, then you're going to have a hard time using them from the JavaScript browser. And there is a way to work around that. You can use the hidden HTTP method filter. The hidden HTTP method filter is a filter that comes with Spring MVC that allows you to tunnel requests coming from the client as GET or POSTs to the appropriate controller method based on a request parameter called _method. If the request parameter is both present and specified in the request, then the filter will consult that request parameter and forward the request onto the right controller. So if you specify delete, it'll route it to the delete controller that matches everything else, right? The URL is the same and all that stuff. It's just got to be a delete controller. So this is good. Now you have full access to all your services, and all you have to do is add a filter. Okay. Let's take a look at how this kind of works in practice, okay? So revisiting our example here, this is our web application controller. Let's revisit a RESTful controller, okay? This is a RESTful version of our customer controller. I've got @controller on the top, and I've got @request mapping. And I've got two annotations here. I've got produces and consumes. These tell the client that we can produce data as XML or JSON, and we can receive and work with data from the client as XML or JSON, right? You don't have to specify this. You could just specify nothing, and then based on the configured HTTP message converters, see what happens based on each request. But this is more sort of declarative and easy to understand and reason about. Once you get inside the controller, it looks very much like an existing Spring MVC controller. So at request mapping, URL, HTTP method, got a response body though, that's different, right? And a request body. So this is almost exactly what we were dealing with before, and that's one of the strengths, right? The component model is exactly what you're dealing with before. It's just that you now have the ability to also work with REST, right? Otherwise, though, this is very, very much sort of, it's easy to sort of pick apart, right? You've got a resource that will be exposed to handle retrieving data based on this customer ID, load customer ID, and it delegates to the service. We have one for, adding data as well. We have another one for updating it. I mean, we have sort of everything you need there, right? And we can actually work with that service. So let's go ahead and load this up. There's a couple of ways to work with it, right? So this application lives in the browser, and I've run the application over here on Cloud Foundry, okay? And I can actually load up some data here in the browser, like this. I can use that data if I want. I can also use this little poster plugin. This poster plugin is a Firefox plugin that you can get for free. I've got a little yellow icon down here. I'm not sure if you can see that. But when I go to the client and I say, okay, I'm going to specify an accept header. So it's going to be application JSON instead, okay? And then I'm going to make the same request. So now, instead of getting XML back like I did in the browser, because I didn't specify any accept headers, I'm getting a JSON representation of that same data. I can omit this. I can change it back to application XML, and then re-request the object, and now I get the XML representation of the same data. So this is a nice feature that's built into Spring and built into HTTP in general. It means that you can expose the same data as appropriate for different types of clients. And you could take this even further. You could, for example, detect that the client can support gzip, compressed data, and then gzip your data or whatever. This also works the other way around, right? So, for example, if I get this data, application JSON, change it, get it, copy the data, and I can send the data, right? So application type is going to be application JSON, and as we saw down here, I can easily just insert data by putting to this URL here, so customers. And I can add or customize this data. So, for example, and then I can, wrong one, fat fingered it, post it, and it gets added to my database, and I get a HTTP 200, and I get a new ID and everything, indicating that the object has been created for me. So I can just as easily, with a very, very simple HTTP client, make and retrieve, send and retrieve data very, very concisely, right? That's the power of REST. If you're looking for a more sophisticated solution, there's something called the REST shell. It's a Spring project. You can actually find out more about it. The REST shell lets you work with resources from the client in an interactive way. So I can specify the URL and then make requests against it, right? So I can just issue, I can say git /, which is relative to the base URI that I just specified. We won't look at this more right now because we don't have a lot of time, but this is a very, very convenient way of interacting with RESTful services in the same way that you might interact with the language of a scripting language at the REPL, right? At a read, evaluate, and print loop. Okay. So that was a very, very sort of simple demonstration of how to both consume and expose RESTful services with Spring. And I know you're thinking, okay, well, so what? What's the point of exposing our RESTful services if we're just going to consume them from an HTTP desktop browser? And the point is, you shouldn't just consume them from an HTTP desktop browser. With REST, you now have the ability to take your application to your users, take it to the devices and the clients that they're using, right? One popular destination these days is mobile, right? Mobile devices are eating the world, right? And sure, if you're building a mobile application today, absolutely go ahead and build for iOS and Android first. It makes perfect sense. You should build native, build something that'll work natively on those platforms, but you can't afford to ignore the rest of the world, right? So, for example, BlackBerry is still very much out there. It's still very much king. You can't afford to sort of ignore them, and really shouldn't, right? You should build something that is at least backwards compatible with them. It's a fall-through experience. Windows Mobile is another common destination. I confess, up until about 6 months ago, I was convinced that Windows Mobile was like the Higgs boson particle for phones. I was convinced that while it was theoretically possible that people were using Windows Mobile, it wasn't provable. Well, of course, since then they've proven the Higgs boson particle, so now I'm just waiting on the proof of Windows Mobile. But nonetheless, you might find them out there, right? They might be out there, and you might have to, you shouldn't neglect them from your application. So it's very common in these situations to build a fall-through mobile form factor specific experience that works well with these kinds of devices. To support this use case, we have the Spring Mobile project. Spring Mobile is basically going to give you a way to render content specific for mobile form factor devices like tablets and phones and so on. And it also gives you the ability to handle requests coming in from a client like that and then keep state on the server about which view they experience, So you've seen this a lot when you go to a website and it says click here to view the mobile version of this website. That functionality, that switching between experiences is something that is all supported by Spring Mobile. So let's take a look at that. We've already seen it, actually. We've already seen this in action earlier on when we created our Spring MVC application and we registered the device resolver handler interceptor. This is a Spring Mobile class. It is used to resolve requests against a knowledge of types of devices, and then give you cues that you can rely on to render content appropriately, right? In our case, we're using Tiles. Tiles is a layout engine for web applications. It lets you compile or composite lots of different tiles and then render them appropriately. In our case, we have a tiles definition, a root definition, that is using a little bit of expression language magic here. It says, okay, the template lives inside of webinf layouts / current device.mobile. Webinf layouts, and then it evaluates this expression. It says, if the current device is mobile, render the mobile directory, otherwise render the standard directory, and then render page underneath that, right? And you can see this break reflected here in the folder structure. Mobile page.jsp is not so interesting for what's in there, but more interesting for what's not in there, right? It's basically just comments, nothing special. The regular page itself, on the other hand, is very, very, very full. Lots of DOMs, lots of JavaScript, lots of CSS and styling, and if you look at the application, it's also sort of very, very, very sophisticated, right? So this is the application that I've built there, and if we go to the URL here in the browser, let's see, and we say 7, and I hit go, I hit enter, I get a pop-up telling me the URL of the record, and then the name of the user, and it prints things out. It's a very big application, lots of widgets that take up lots of screen real estate. I'm also using Dojo. Dojo is a nice, if a bit heavy, JavaScript library, so this is probably not the most appropriate experience for a mobile device, right? I can then take the same URL, the same application, visit it inside of a Android emulator here, right? So I'm going to go ahead and launch the browser. And if I go to ID 7, right, same thing as here, I can do this. I can do ID, go 7, and that gives me, it pre-plugs in the number for me, and I can do that. I can do the same thing in the mobile browser in my Android device, and hit enter, and then go for it. And I get now this other, much more simplistic experience, right? This basic HTTP and HTML page. So you have a lot of power there, right? You have the ability to render a client and render an experience for devices based on their quality, the characteristics that we can glom from each request using the device resolver handler interceptor. Okay, so that works just fine. That's a great way to solve that kind of problem. But like I said, if you can build native, you should, especially for the two big markets. Android in particular is everywhere, right? It's the largest market for applications. It's fast becoming one of the largest platforms ever, desktop or form factor, desktop or mobile form factor, in either way. It's a very, very good opportunity for Java developers as well because the syntax is very, very similar. In fact, it's identical. The classes that are available are not quite the same as what you're used to, but still, it's very easy to get started, right? So we have the Spring Android project. The Spring Android project provides the REST template. It provides support for consuming RESTful services from within an Android environment. It also has support for working with OAuth-secured services like Facebook and Twitter. And generally, it's just a very good experience, right? A lot of people ask, okay, well, does Spring Android support dependency injection? And the answer is, at the moment, no. And the reason is because Android itself imposes constraints on the life cycle of objects that are used in Android, such that there's no opportunity for a technology like Spring to get in there and intercede on your behalf in the creation of objects, right? There's no ability for Spring to provide services and so on, because Android starts everything up without, consideration from anything else. But that's okay. In most cases, you don't need it. There are other, quote-unquote, and I use the term charitably, solutions to this for dependency injection, but they're pretty, off-putting. Some of them require base classes. Some of them require compile time weaving, compile time changes. Generally not worth the complexity, in my opinion, but feel free to pursue them if you like. Nonetheless, the REST template on the client works very much the same as it does on the server. So here's an example of using the REST template to make a request against the URL and actually, send data, a custom object with a type, and then sending parameters using the path variables. Same thing you might expect in the server-side version of the REST template, right? Okay, so with that, we can now revisit our little application here. And I can go here, go to the applications in my Android emulator here. I'm going to launch my little Spring CRM. I've got a little application here. I can type in a number, type in edit. My name is Josh Long, but my given name is Joshua Long. I don't much like it when I'm called Joshua because it reminds me of, on the rarest of occasions when I get in trouble with Dear Sainted Mom. But nonetheless, that's my real name, so I'm going to go ahead and save that here. And then I can see that information now reflected, in the data coming from the service, right? So from the desktop application or from the mobile form factor application, they all reflect that data. Okay. So we haven't had a moment to look at things like Spring Data Rest, which provides support for transparently exporting repositories built on Spring Data, Spring HATEOAS or HATEOAS, hypertext as the engine of application state. It's a best practice and a pattern for RESTful architectures. Definitely recommend it because this project makes it easy. Spring Social is a library full of clients for working with social service providers, with OAuth. Spring Security OAuth makes it easy to expose your services through REST and secure them using OAuth. All right, so now if we have questions, let's see. How are we doing on questions, huh? Oops.
We've got a few teed up, Josh.
Sorry?
We've got a few questions teed up.
Okay, where's my... I'm looking for...
I can MC them for you. We have one from a guy named Paul Verest. He's curious for the mobile...
Hello?
Yeah, there's a question from Paul Verest. He's curious for the source for the mobile MVC.
Oh, it's all here.
Source code.
Josh, it's github.com/JoshLong/ a walking tour of all of Springdom. And it's a folder, right, under the web folder. So walking tour, and then click on web, and then click on mobile MVC. And the Android code, the Spring Mobile code, all that stuff is all here.
Great. I'll see if I can cut and paste that into the chat window so people can also cut and copy that.
Okay, I will do it for you.
Oh, great. Fantastic. Thank you.
Well, I can't find the window, actually, so you can go ahead and do it.
Yeah, I'll take care of it.
Thanks,
we had another question from the same gentleman, from Paul. What is manifest.yml?
That's a Cloud Foundry descriptor. This just simply tells Cloud Foundry, which is a open source platform as a service that I'm using to host this demo, the makeup of the application, including which databases it needs and so on. So that way, when I deploy the application, I don't have to re-stipulate everything. It just installs itself. So if you take this code and you set up a Cloud Foundry account, you just do VMC push, and the application will set up a database. It'll set up everything it needs. You don't have to worry about how to set up the sample.
Excellent. Okay, so it's kind of like a deployment. Well, would an analogy of saying it's like a deployment descriptor for Cloud Foundry be completely inaccurate? Okay.
No, that's perfect.
Okay, fantastic. I have another question come in from Gopi K. Can we use XML configuration for the web config? Which
Absolutely.
is ideal?
Yeah.
Hold on. Which is ideal, whether to override the abstract class or just use what Spring provides and config in the XML file?
You have your choice, right? So this is not an either or. You can use both, in fact. I happen to like the Java configuration style. Remember, there's almost nothing you can do in XML that you can't do in Java configuration. You're free to choose whichever one you want. I use the Java configuration just because it's type safe. Nowadays, you don't even need web.xml. So you can use initializer classes, which Spring supports, right? And that'll actually give you a chance to configure your web application just as you would with web.xml. So you don't need web.xml, and you don't need the dispatcher servlet XML files either. You can just use Java configuration the whole way through. But you can also use XML. It's not going anywhere. It'll always be supported. The effect is the same, right? It's just a matter of your style.
Excellent. Okay. Had another question from Bassem Zodi. Hopefully I'm saying his name correctly.
Hi, everybody.
He's curious, the XML default message converter, does it have issues with array lists, and how did you solve it?
So yeah, there can be some issues with marshalling based on the kind of technology you're using. The array list, I'm not specifically sure about your question with XML, but I know people have successfully managed to map collections using JAXB, right? There's lots of blogs on the internet. I don't have the answer off the top of my head right now, but I know, for example, JSON with Jackson, it's very common. A common complaint is, well, I've got a circular relationship in my Hibernate object, and I want to marshal that into JSON. But of course, if you do that, you get this circular reference problem with the Stack Overflow, and there are actually solutions for that as well. Like there's a Hibernate-aware object mapper that you can plug in. But yeah, go ahead and if you can send me an email to josh.long@springsource.com, I'm happy to look at that for you. I don't have the answer offhand.
Okay. Got it. And another question coming in from Gopi K. Does Spring provide dependency injection for Android in the future? Or will Spring provide dependency injection?
We could, in theory. I mean, it's sort of, can we do a good job of satisfying the use cases that our users have? And right now, we're seeing a lot of people are moving to Android. They're building applications of some complexity, not necessarily of the complexity that you kind of need dependency injection, but certainly one of the places where we can add values and making it easy for them to consume services through REST, right? So that's why the REST template is there. Dependency injection itself, we will continue to monitor the platform and the market and see if there's an opportunity there. At the moment, it's we wouldn't be able to do anything different than the other guys, right? And those solutions aren't very pretty for the reasons I mentioned before.
Gotcha. Another question coming in from Carlos Martins. Is REST suitable for large applications with thick clients or fat clients that may, for instance, display a bank loan contract? Hold on, there's more to it. Display a bank loan contract, and all its related data and even actually update some of the details, how would it merge with the Hibernate session data on the server?
So remember, REST is stateless. So you will, it'll work with session data in the same way that I've demonstrated here, right? I mean, in my code, all these examples, all these different services, they basically just delegate to a regular Spring transactional service, right? Which in turn is using a JPA, right? I've got a couple of implementations of this, but they're using JPA, right? So it works just like that. You create a service and write to it. You're not going to keep a Hibernate session open across, transactions, right? Across requests into the service tier. There's no need for that. And yes, I absolutely recommend it for any kind of application, for bank or not, for thick client, for thin client, because as I mentioned before, they all support HTTP clients, and it's easy to access these things from those environments. And then more to the point, you can also secure it. You can also do things like encryption and all that stuff. It's very easy to plug in. It's easy to scale. Totally recommended it. Because again, it's just stateless. It's just HTTP. So Apache can be used to add. You can load balance with just regular old Apache. You can't do that with RMI or Corva or SOAP or whatever. Well, you could with SOAP, but even there you can have state. So best avoid.
Excellent. Thank you. Another question from Gordon Railing. He's referring to an earlier Spring Source webinar that we talked about building JavaScript apps. So I think he's probably either referring to Scott Andrews' Architecture of Modern Web App, or possibly John Hand's IOC and JavaScript webinar. I'm not sure which one.
Cool.
Basically, he said earlier we talked about building JavaScript apps, Node.js, etc. How does this fit with the device capability rendering that you have talked about?
So again, those are client-side stories. I completely recommend you look at those libraries and use them in lieu of the, I use Dojo in this example because it's very familiar and people know it. But the libraries that we talked about in those webinars are very, very powerful libraries for working with RESTful services and for building data-driven, data-centric client-side applications. And those applications would, in turn, connect via REST. When it comes to rendering specific views, right? So forget about REST, but just talking about specific views or experiences like we did before in our application. Spring Mobile is still going to provide a better experience because you can short-circuit. One approach is to send down all the data, and then on the client side, based on the logic on the client, to render or display yourself a little differently. But that still has the drawback of requiring that all the data be sent down the pipe, and that can become burdensome for mobile phones, right? You don't want to send all the images and all the JavaScript, and then after it's all loaded, decide you're not going to render most of it, right? The device resolution capability that I demonstrated is on the server side, so you render a much smaller, much more svelte page for the phone and tablet, device. And then for the desktop browser, where presumably somebody's plugged into Wi-Fi, you send them the richer experience, So they work together. So my point is the JavaScript and the server-side stuff work together very nicely. And you still want to, hey, thank you. You still want to use both if you can.
Yeah, and if I can just throw in a comment there, I think the Cujo.js stuff and the JavaScript things that we might have seen on earlier webinars really focus more on things like dependency injection to JavaScript and are bringing kind of more horizontal concepts that I think can apply on the server side or the client side, and they're just complementary and different as opposed to what Josh is talking about today. And I encourage everyone on the phone who is dabbling in JavaScript to go check it out and take a look at Cujo.js. Absolutely.
It's all one stack. Okay. It works very nicely together.
So we have another question coming in. What is your opinion about cloud? This is from Bassam again. What is your opinion about in Cloud Foundry UAA?
Very interesting question. Cloud Foundry UAA is the authentication and authorization agent for Cloud Foundry. It can be used a lot of different ways. One way you might use it is as an OAuth client. So you can say, dear Cloud Foundry, I would like to access, Josh's Cloud Foundry account on his behalf and administer the cloud for him. So you can actually use that as a way of controlling Cloud Foundry. But more generally, you can just use it as an ID provider, right? In the same way that you can use Facebook to log people into applications, you can use UAA, and you can say, I trust the information that I've gotten from UAA. I know that if it says Josh Long, it actually is Josh Long and all that stuff. Just like I trust the information I would get from Facebook, and you can use that to short circuit, for example, sign-in forms, right? You can just say sign in with Facebook or sign in with Cloud Foundry. I mean, there's lots of options. So I think it's really nice. It's actually built using Spring Security OAuth, which I talked about ever so briefly earlier, and you can expose an OAuth service for yourself if you like as well, right? Using that same technology.
Sam was actually asking about documentation for Spring Security OAuth, saying that he was having trouble finding it. Do you have any perspective on that? Or I was kind of assuming you didn't, but
you should have the documentation should be on the website. Let me see, Spring Security, and then also I invite you to check out github.com/JoshLong/the Spring tutorial. And in the master branch there's a complete working application, complete with Spring Security OAuth integration. Documentation should be good.
That's okay. I think
yeah, it's all here. Tutorial, user guide, support, all that stuff.
We do have a couple of other questions. So
okay.
Yeah, I think Bassam's perfectly capable of surfing the web.
Mm-hmm.
But clearly he's not finding something he's looking for. So maybe he'll clarify and specifically
send me an email.
Find. Yeah, I think that's a good way to handle it. Let's see. Okay, GoPK, another question. Actually, I'm not entirely sure if this is a question, but he's saying, since network is becoming broader, in the future, can we move to thick clients and get more features? I'm tempted to also respond in that this is kind of what we're seeing happen with JavaScript and people moving MVC frameworks off of, some people looking at moving MVC frameworks off of the server side and into the client side, creating thicker clients. But I don't know, you might have a different take on that, Josh.
Yeah, basically, we're seeing people, echoing your point, we're seeing people move to the browser as the client of choice. If by thick client you mean more traditional like Windows Forms or Flex or Adobe Air kind of things, you could use REST from those platforms. But as I mentioned before, HTML5 is now very sufficient. I mean, you can actually boot Linux. So there's probably, if you're trying to do something, unless you're actually I can't even think of use case. If you're doing 3D games, you can still do it inside of HTML5 and Canvas and OpenGL. You can do video, you can do audio. So if you want to do fast data grids and all that stuff, you can do all that stuff just as fast in the browser now. JavaScript is very fast. But yeah, you can still use REST from any other kind of client as well, thin, thick browser.
Yeah, I mean, remember we've got years of, JavaScript is just kind of emerging into this area in the last couple of years, right? The enterprise out there might have, Swing and, all kinds of other stuff. So,
yeah.
But I mean, REST should be accessible from pretty much any client that has they can.
Yeah. Totally.
Meant to cross languages and environments. Let's see. Okay, got a question from somebody different, so I'm going to kind of poke on that one. This one's from Alam Hussein. Hi. I received JSON data into my RESTful service. The JSON data I receive is composed of lists of objects. Spring maps the JSON data into lists of linked hash map objects. How can I ask Spring to develop lists of POJOs, but not of linked hash map object?
Good question. I don't know the answer offhand. I imagine you could tailor the Jackson support in some way. There's lots of different knobs and levers you can pull when you configure the Jackson marshalling HTTP message converter. You would do that inside of your web configuration class, right? But I don't know the specific story for your specific use case. But I do invite you to send me an email. So please, josh.long@springsource.com, so I can get a better idea of what that is. I don't know the answer at the moment. So there's your email, and you configure that in this thing here, right? so web MVC configure adapter, and you would override the configure message converters method. And there you can message converter that does the mapping a specific way.
Very cool. Ooh, this looks like a good question. This is from Shijin Raj. Oh, wait a minute. Sorry, wrong one. From Gordon Railing again. Does Spring Mobile identify whether you are Wi-Fi connected versus 3 or 4G connected?
I don't know. That's something you can. Some browsers have support for detecting whether you have Wi-Fi support. I don't know if you can actually drill down into whether they have 4G or 3G or not. But that's not a server-side capability that we can detect from Spring Mobile.
Got it. Okay. So then Shijin Raj asks, do we have a database reverse engineering tool to generate Spring MVC 3.1 annotation-based applications?
Spring Roo will generate XML, Spring MVC XML-based applications, and that's pretty easy to convert, but no, otherwise we don't. Spring Roo can be used to generate, standard XML-based Spring MVC applications based on reverse engineering a database, right? Same with there you go, that's the answer.
Let's see. Okay, wow. A bunch more questions coming in. This is interesting. Let's see. Oh, this is you might get a giggle out of this one. Renee asks, I want to use a Oracle ADF in Spring. Is that possible?
You can. Oracle ADF is now Java Server Faces, right? So yeah, you can use. Spring has support for Java Server Faces. The wisdom of using Java Server Faces itself, notwithstanding, there's no reason you couldn't use it with Spring. There's good support for that. We actually support dereferencing Spring Beans from inside of Java Server Faces, backing beans, and inside of expressions as well. JSF expression language. You can dereference Spring Beans managed by the container. I don't know if I think that's what you're talking about. If you're talking about the JSF version of that, right, the Oracle Faces and all that stuff, then yeah, that works fine.
Yeah, I've got to assume that that's what he's talking about. I mean, because ADF covers a whole bunch of other topics, but that's probably the one that relates to what we're talking about here.
Right.
Chiwei2 asks, which version of Spring supports @response body annotation?
@response body came inside of Spring 3.0, so if you have used any of the new versions of Spring since 2009, then you can take advantage of that annotation.
Okay, very good. Let's see. Okay, just one sec. Cherry picking a couple other questions here. Shijin Raj asks again, how can I migrate an existing Spring MVC application to support Android, Windows, and BlackBerry mobile easy browsing model? Not quite sure what he means by that.
I'm not sure either, but I expect that that's probably some sort of client-side specific experience that you can expose. For example, I'm not sure if this is the same thing, but for example, in some TVs, they have applications that feature a lean back mode or a passive mode where you just sort of turn it on, and because it's an application connecting to a website, it just keeps auto continuing to the next next bit of content. You don't have to manually interact with it or drive it from a keyboard as you might from a typical web page. That's all something you would support on the client. And the way to build all those kinds of apps is to take advantage of the native client APIs there, or the JavaScript or whatever, and then use REST, right? So if you're going to try and move an existing Spring MVC application, and you're going to try and support all these different types of clients, the way you need to do that is to stand up RESTful services and then consume them as appropriate from each client, right? That's how you reuse that data, that service. But there's no such thing as a portable UI that works on every device. That's we need to embrace that reality and just build client specific for each one. But at least we can share the same services, the same business state with REST.
I had a couple of requests for the PowerPoint or PDF. Would you be willing to post a PDF into your GitHub repo?
Slideshare.net/Josh Long. This talk is there.
Oh, great. Okay. I see it right there on the screen.
Yep.
Sorry about that. Yep.
I will put it in the Git repo if you absolutely want, but
The face of the emu distracted me so much that I didn't actually read the text.
I love that email.
Let's see. Yeah, he is cute, huh? Okay, so we got. I think Bassam Zodi is going to win the tough, the tough question award for the webinar so far. So here's the hardball.
For last, huh?
Do you face the coarse domain model issue with REST and JavaScript? I think what's implied in that is sort of where do you put your domain model when you're
coarse domain model. I'm not sure specifically what that refers to, but generally, this application.
I think what he's getting at is where the how fine grained or how coarse grained do you make your domain model when you're using like REST and JavaScript and you're having these more intelligent clients. This is a tricky one, I think. Yeah.
In my example, I've been using a very, very simple demonstration using Hibernate, and in this case, the data I need from the service maps very nicely to my service data objects. Very often, though, we see there's a DTO, something that is going to contain either less data than the service model or, in particular, extra data that is specific to the client. And so you have a wrapper object. It's very common you see that. So at the Spring MVC RESTful controller layer, you might have a separate hierarchy of objects, and those are adapters around service objects. And that domain model is more specific it's properly set up so that when you send it to the client, it contains information that the client will need, even though it's either a subset or a superset of the actual domain model that the server side happens to have. In this case, I don't have two hierarchies of objects. I have just one because I'm doing it. It's a very simple demonstration. I would keep a client object domain model that makes sense. If it means you have to create a separate hierarchy, that's fine. Spring MVC doesn't require you to use your own domain models. You could just use regular HTTP responses.
Hang on. A gentleman named Raphael is putting some notes in here, and I think he's trying to peg it to this particular conversation. He's saying he believes that the question is actually about cross-origin resource sharing, CORS.
Cross-origin?
Yeah, he put in a link to a Wikipedia thing. Maybe this is one that we take on email, but
yeah.
If that doesn't trigger something for you, but I think he's trying to help us out in clarifying.
Yeah, let's do it by email. I'm happy to look at that.
Yeah, okay. We're going to be running out of time pretty soon, folks, because we're almost 30 minutes over. But we like to stay on to try to answer as many questions as possible because, well, that's why we're here. And we are getting towards the tail end of the questions. Let me just see if there's a couple more, and then we're going to have to wind this up and call it a day. Let's see. Okay, bear with me for a second, folks. This is a good one. Carol Kopax, Carol asks, what is the recommended approach or technology for securing REST requests?
I would definitely recommend you take a look at our Spring Security OAuth project. OAuth is a security, it's a way of authenticating users. It's a way of verifying that the user that is accessing the data is the user that has the right to access that data. And it does this by requiring the user on whose behalf the service is acting to give permission to that user. So you see this a lot when you go to Facebook and you install some sort of game or whatever, and it says, do you authorize this game to access your Facebook wall and your profile? That's OAuth. And you can expose the same thing for your application so that if a client connects to your service, it prompts the user on whose behalf that client is connecting to give permission to that client, right? So we support that very easily. It sits nicely on top of Spring Security. It's called Spring Security OAuth.
Bassam, again, winning the Hardball Question Award for the webinar. What do you think about the RESTlet integration with Spring and Java REST standard? Is it going to go over MVC of Spring?
I haven't looked at RESTlet, the RESTlet framework in particular. I hear it's pretty good. I don't know what the support for Spring is. Spring itself has a very, very good situation. We have a very good stack in that Spring MVC supports REST, but then we also have Spring Security OAuth to provide a full security stack. We support HATE-OAS, which is a architecture pattern and practice. We support Spring Social for consuming RESTful services that are secured with OAuth. So we have the full stack, right? And we have client-side support in Android. Plus our integration at the Spring MVC level is very natural, right? As you saw, we have the Spring MVC add controller component model, and then with just an extra annotation or two, you now have REST support. You don't have to learn a completely different stack. So in this respect, I think we have a very compelling offering compared to things like the JAX-RS.
Awesome. All right, folks. I think there's only like one or two questions that I actually didn't get to. So, and we're almost 30 minutes over. So,
okay.
Thank you,
guys.
I think this is a good conclusion point. Josh, any sort of last kind of calls to action or conclusion comments before we wrap it?
Check out This Week in Spring every Tuesday on springsource.org. Feel free to follow me on Twitter at StarbucksMan. If you have questions, like I said, I'm genuine about this. Send me an email. I'm happy to help. Always happy to help.
Thanks, folks. And please make sure you join us again for the next upcoming webinar. We are going to, if you're interested in using Spring integration or Splunk, which is a pretty interesting product, doing log file analysis, among other things. We're going to be having a webinar later this month, and I believe the date on that is, just a second, I think it's in the 20th. I think it's, sorry folks, just 1 second. Should have had that ready, I apologize. That's Damian Dallymore, who spoke at Spring 1, is going to be presenting, and that is on March 28th.
I'll be there.
And, we'd love to see you there, so please join us. This is going to be the initial release of a new Spring integration channel adapter for Splunk, so that you'll actually be able to plug Splunk right on into Spring integration. So all you Spring integration fans, hope to see you there. And thank you very much for coming today. Appreciate all the questions.
Thank you.
And look forward to seeing you soon.
Thanks, guys. Bye-bye.
Bye-bye.